All right, so I'll do an ls, and I'll ls into the assembly directory to take a look at the file. All right, so this is going to be my input file. So this is our assembly data, which has the context. So we are going to identify antimicrobial resistance genes in this data. So I'll use STARAMR. So to identify antimicrobial resistance genes using STARAMR, we say STARAMR and we say search. And then I'll indicate my output directory. So that will be -o. Then I'll specify the name. So it will be the sample name, and I'll add _STARAMR. So this directory will contain the output files. Now let's specify the input file, which is assembly.fasta. So that will be assembly/assembly.fasta. If you are going to use your own input file, then you can just change the output directory name and then the file name here. All right, so this is what we are going to do. Now, STARAMR, in addition to identify antimicrobial resistant genes, also identifies plasmids, and it also tries to do some multi-local sequence typing as well. It does that, so you get the MLST results as well. There are other files it generates, and I've covered an entire tutorial on that, so check the description box, you'll find a link to that tutorial. Okay, so let's continue. So let's execute this command to run STARAMR. All right, so STARAMR is being executed. All right, so in some cases you may identify this error message here, but don't worry, we are going to resolve it. So this is happening because the current STARAMR version I'm using, one of the commands is not compatible with the pandas version that was also installed. So pandas is a Python library. So what we are going to do is to resolve this issue. So we resolve it by first removing that pandas version and then installing an earlier one, an older version. So that's what we are going to do next. So let's clear the screen and continue. All right, so I'll use pip to remove the pandas library, the current one. So I'll say pip uninstall pandas. I'll confirm the uninstallation. All right, so pandas has been removed. We are now going to reinstall, but this time we will use an older version. So I'll say pip install pandas equals 1.5.3. This worked for me, so I'll use this version. So I'll execute this command, and then pip will install that version for me. All right, that version has been installed, so we can proceed. Now, before I rerun STARAMR, I will have to remove this directory because I'll use the same name, so I'll remove it here. So I'll say rm-fr, and then I'll remove it. You should be careful when using the rm command because once you execute it, there's no coming back. Your files are gone, so be careful. All right, so let's proceed. I'll just redo that again. All right, so let's rerun STARAMR. So I'll say STARAMR search -o, and then I indicate my output directory, and then I'll specify my assembly file. All right, so let's execute this command. So this time STARAMR will be able to do its work. All right, so everything has been done. So with this one, you can ignore it, that's fine. It's It's nothing to get worried about. Okay, so we have been able to successfully execute STARAMR. I repeat, we have been able to successfully execute STARAMR. So we have the outputs. Let's take a look at them. So let's do an ls. We will have our output directory being displayed for us. So this one here. So let's ls into it. And we are going to find our files there. So we have a couple of files. Now, these files, a description of each of these files can be found on the STARAMR page. I will leave that link in the description box. Now, I've also covered an entire tutorial on that as well. So you can check the description box for all those materials. All right. So we are going to open some of these files, by the way. So I'll do that using my file manager. So let's go and then take a look at the files. All right, so these are the output files. So for this tutorial, I'll focus on just this one and this one and this and this. So you can open any of them with a spreadsheet software. So let's take a look at the REST finder. So this one has information about the antimicrobial agents. So we can open it with a spreadsheet software and then look at what we have. So each row is a hit, a record. Each row represents an identified AMR genes. So we have the isolate ID here. It will be the same name because we specified just one file. And so all the hits are in that file. And we have the gene name. We also have predicted phenotype, percentage identity, overlap, etc. We also have contigs. So here, because we have more than one contig, if a gene is identified on a particular contig, then the name of the contig will be indicated here. So this will let you know which contig that gene was found on, that AMR gene was found on. So here we have contig 2. We also have contig 1. So here it tells us that contig 1 and 2 were the ones which had the AMR genes, the antimicrobial genes. So we have the details here. All right, we also have accession number. We have start, end, accession number, sequence, etc. So you can look the gene up using the accession number. Let's take a look at a discussion on the Galaxy tutorial page here. So the Galaxy tutorial page also gives the files and it gives a description. So you can read that or visit the developers GitHub page. I mean the STARAMR developers GitHub page. All right. There's also a discussion here about multi-locale sequence typing. So with the multi-locale sequence typing, the Galaxy tutorial page makes us know that using error-rich sequence data like nanopore, that's long reads, then it's going to be challenging if you try to perform MLST using such kind of data. So you are better off doing it using a short read data, i.e. Illumina. Okay, so that's what this statement means, but I would like you to read it yourself and then try to get the information. And we also have plasmid and then antimicrobial genes. So we have the information here. We also have this one here. It says multiple rep sequences are located on the second contig. So the second contig, ours may be different because we have a slightly different results. So what I have to do is check if you can find the rep sequences. So here, the rep sequences here are found on plasmids. And so what this indicates is that since there are rep sequences, that means that our sequence data likely has plasmid or plasmids. Let's take a look at our file. We will look at the plasmid finder file. So this has information about plasmid. So let's open this also. So if you open it, you will get information. So we have rep sequences. That's what the tutorial is referring to. So we have them here. We have the contigs. So yeah, we can see that rep sequences have been found in all the contigs. So contig 2, 4, and then 1. They all have rep sequences. And then we have the identity here. So identity here is less than 100. So for me, if it's less than 100, I'll want to do some other checks to make sure that these are indeed plasmids. But I mean, once you have these ones here, and then the thresholds to, you decide the threshold. So for me, I'll go for 100% identity, but it depends on what you want. You can also look at having a threshold less than 100 and then decide if the hit you have is indeed a plasmid or not. Okay, so that's what we have here. And then we also have the session IDs to let you know them. So you can just set the session IDs to check the information about that.